morning, students. I am Sankan, working as a physics faculty in Target English Medium School. So, in our past two videos or previous two videos, in the chapter of force, I am clearly explaining what is the force and what is the exact definition for force. That is nothing but who give the exact definition? That is nothing but Newton, scientist. And after that, what are the changes can be produced by the force? That topic also we discussed. And finally, what are the types of forces in the nature? How many are there? And what are the forces are called contact force? And which forces were called non-contact force or force at a distance, with help of some suitable explanation. Now, before going to the next concept in this chapter, I am asking two questions. That's why you can try to find the answer. If you cannot find the answer, please ask me through the WhatsApp number. So now what is the first one? Means just simply here it is a table. We placed a book on the table. It is the book. It is a table. Listen very carefully. A book is placed on the table. Initially, book is in the rest position. During that condition, on the book, frictional force is acting or not? That is the first question. Listen very carefully. When a book is placed on the table, initially it is in the rest position. During such condition, frictional force is acting on the book, or frictional force is present or not. That is the first one. And the second one is and the second one is same concept again. You can take the two bodies A and B. It is the A, it is the B. Listen very carefully. You can take the two bodies or two bricks A and B. The two bodies will be placed one upon the other, like as shown in this figure. Like this one. So on these two bodies, how many forces are acting? That is, you can write. That is the What is the first one? If a book is placed on the table, it is in rest. Is frictional force is acting on the book or not? That is the first one. And the second one. So in this diagram, on the A and B bodies, both are kept one upon the other. During this condition, on these two bodies, how many forces are acting? Initially, they are in the rest position only. That is the second one. So next topic is, what are the differences or simply distinguish between contact force and non-contact force? So means what type of differences mainly we are observing between the contact and non-contact force, or force at a distance, or field force? That is. Now here, generally, this topic is very important, for any point of examination in 8th standard level, for 4 marks mainly. But in this one, listen very carefully. Differences are distinguished, like the type of making of the question you are observing. You must be draw a tabular form like this one, and you must be show the comparison or differences. So that's why, like this one you can draw. CF means you can write full form. Contact force, force at a distance. It is also called as a field force or non-contact force. So how many differences you are observing? Means simple. Initially, Okay, first you can write the definition of the contact force. Okay, under this side, and the definition of the force at a distance under this side. Okay, means so once again I will be telling a force which occurs a direct physical contact between the two bodies. That force we are called contact force. Next, a force which occurs without any physical contact, that body, okay, sorry, that force we are called force at a distance. Next, what is the second one? Means, okay, contact force is depend on the area of contact. So listen. So contact force is depend on the area of the contact of the two bodies. Means if that okay occupies the more area, means for example when a body is placed over the other body, at that time okay, so upper body will be occupy some surface on that one or not. For example, you are observing that okay, like here a table where I can say that. So on the table we placed a small object like this one. That's why here, so when a small object is placed over the table, it will be occupies only this much of area. Area means length into breadth. Okay. Just we are consider it is the only okay 10 centimeters square. So so means area is equals to length into breadth. Okay. So for example, it is a okay cuboid shape or rectangular shape. Sorry, rectangular shape we are considered that. So its area is length is 10, breadth is 1. Just you can say that. So 10 centimeter is the length, breadth is 1 centimeter. Then how much area it is occupied on the table? Only 10. Now the same thing we can place another one is there, means larger one. So length is more same. Okay, breadth is 1 centimeter, but length is for example 20 centimeter. Then what is the area? 20 into 1, 20 centimeter square. And one more thing we are observing that okay. So generally we are observing that when okay a duster, generally the duster is in which shape? Rectangular shape. In this one, when the duster will be placed horizontally on the surface of the table, it will be occupies the more area on the table. That's why more surface area of the okay duster is contacted with the surface of the table. Due to that reason, a strong okay contact force is acting. But the same thing okay. So that's why if next, due to that one, if this duster we are displaced means we can apply some little bit force, means some more force. But the same duster we placed in vertical mode. When you place in vertical mode, what will be happen? You are observing that it occupies the very lesser area on the surface. That's why just you can tap with a little bit force, automatically it will be fall down. So means okay. So area of the contact is more. Contact force is also more. Area of the contact between the two bodies is less, but contact force is also less. Next one, force at a distance under this one. Okay. Force at a distance or field force is depend on the distance between the two bodies. Listen very carefully. Okay, so contact force is depend on the area of contact between the two bodies. Force at a distance is depend on the distance between the two bodies. We are observing that in case of magnetism. Okay, when you can take the two magnets, if okay, north pole of the one bar magnet, south pole of the another bar magnet, when you can bringing very near to each other, at that time okay you observe more force of attraction is present between them. But when they move away from each other, or one is keep in the rest, another will move away from the first one, you are observing that okay there is no force of attraction. So what is the reason? If the distance is less, attraction force is more. If distance is more, attraction force is less. Is nothing but, okay. So force at a distance between the two bodies is depend on the distance between the two bodies. Distance is less, either attraction or repulsion force is more. If distance is more, attraction or repulsion force is less. That is the meaning of that. And the third one, so what are the examples? You know that muscular force, tensional force, frictional force and normal force are the examples for which force? Contact force, force at a distance, gravitational force, magnetic force and electrostatic force are the examples for the force at a distance. Once again listen, what are the major distinguished between contact force and force at a distance means? So three are there mainly. First one is the a force which occurs a direct physical contact between the two bodies, that is called contact force. A force of attraction between the two bodies, a force which occurs in this one also, a force which occurs a direct physical contact between the two bodies. A force which occurs without any physical contact between the two bodies. Next one, it is depend on the area of contact. It is depend on the distance between the two bodies. Muscular force, tensional force, frictional force, normal force are the example for this one. Gravitational force, magnetic force and electrostatic force are the example for this one. Okay, so now our next main concept is net force. What is the net force? Net is nothing but simply total. Okay, for understanding of you only. Okay, so what is the net force means? If two or more forces are acting on a body simultaneously, listen very carefully. If two or more forces are acting on a body simultaneously, that force we are called as net force is acting on the body. Okay, for example, I will be told to you one thing here in this time. It is, we are considered as a table. Now we can take a 2 kg mass of a brick. It is a brick. We have considered that. A 2 kilogram mass of a brick is placed on the table. When the brick is placed on the table, on the brick, how many forces are acting first? Okay, only one force or two force or three forces. How many are acting? I will explain. So initially we discussed already. Okay, which force is acting downward? Gravitational force. Because of every body on the earth is attracted by the gravitational force of the earth towards the center. That's why on this body, earth attraction force is acting vertically downward. That is called gravitational force. But at the same time, on the brick, only this force only acting. If gravitational force only is acting on the brick, what will be happen? It must be moved to downward. But it is not possible. Still, it is in the rest on the table. Okay. So here, what you are understanding? Table is generally made up of iron or wood. Okay. That's why the surface of the table, it is either made up of wood or iron. It is very rigid. That's why the rigid surface of the table will be apply some force on the brick in vertically upward. Is nothing but against or opposite to the gravitational force. That's why it is this force we are called normal force. Listen very carefully. Okay, already we discussed in the concept of normal force. A force accepted by a rigid body on the another body when it is placed on it. That's why brick is placed on the table. On the brick, vertically downward, gravitational force is acting. But brick does not move to downward along the direction of gravitational force. Means on the brick, some more force is acting opposite to the gravitational force. Then here, gravitational force is equal to which force? Normal force. Otherwise, it will gravitational force is more, it will be moved to down. Normal force is more, it will be moved to up. But it is not possible. We know that because of gravitational force is always balance the normal force is always balance the gravitational force. According to this one is nothing but the magnitude of the gravitational force is always equal to normal force in case of rigid body surfaces, but opposite direction. That's why on this brick or block, how many forces are acting? Two. That's why we are considered the net force concept. Gravitational force we are considered as a F1, and the normal force we are considered as a F2. If it is we are considered the F1, it is F2. That is your wish only. That's why what I say is that if two or more forces are acting on a body simultaneously, that force we are called which one? Net force. That's what we can write F of net. Means net force, that is the meaning of that one. F of net is equals to, here F1 minus F2 or F2 minus F1. But generally, when you are using this equation, means simply, so if the two forces are equal in magnitude, we can write the formula F1 minus F2 or F2 minus F1. Otherwise, one force is more, another force is less. Which one has the more force? That is, you can write the first. Next one is the second. That is, you can keep in your mind. That's why F of net is equals to F1 minus F2 or F2 minus F1. Here we are observing that how much kilograms of brick we are taken? 2 kg. This is the main formula for net force. For understanding of you, I will tell one concept here. What is the mass of the brick? 2 kg. That's why what is the gravitational force? I say that is nothing but weight. M is 2, G is 10 meters per second. 2 into 10, 20 Newton. That's why 20 Newton force means the brick is pulled by the earth with how much force? 20 Newton. But brick is in the rest position means what is the normal force? Same 20 Newton. That's why F1 is 20 Newton, F2 is also 20 Newton. Means magnitude means nothing but numerical is equal or not, but direction. Gravitational force is downward, normal force is upward, means direction is opposite. That's why here F1 is in downward direction, F2 is in upward, means F2 is opposite to the F1. That's what we can take it as a minus. So what is the F1 value? 20 for understanding. Minus what is the F2 value? 20. So that's why what is F1? Total 0 Newton. Means on the brick two forces are acting simultaneously, but the net force is acting on this body is 0. Due to that one, the body cannot be moved either downward or upward. That is the main concept. Now we discussed some more examples in this case. Same in the net force concept. Some numericals or some concepts we discussed there. Case 1 for example. So what is the case 1 means? If two forces acts on a body, listen very carefully. If two forces acts on a body in same direction, so two forces are acting on the body in same direction. What is the net force? That is it. Now come to that one for understanding of it. So we are considered it is a table. It is a table. Now here, so the table is initially rest position on the ground. Now on this table, one person we are considered. he pushed with F1 force, and another person is also we consider. Okay, bracket is not good. Just okay. So two persons we are considered that A and B. A person is okay apply the F1 force on the table. Then at the same time B person is also apply the force on the table with F2 in the same direction. Is nothing but F1 and F2 are A and B. These two persons are apply the force on the table or push the table at a time with F1 and F2. Understanding or not? That's why here we are observing that according to the Earth magnetic field. So east, west, north, south. That's why from this diagram, okay, A person is apply the force on the table during the pushing in which direction? E. Like the same way, B is also push the table in which direction? E. Means east side. That's why both are apply the force or both are push the table in the same direction. During such condition, I say that here, how many forces are acting on the table? 2. When 2 or more forces are acting on the body, that force we are called net force. That's why what is the formula to find during this condition means F of net is equals to okay F1 plus F2 because of both are acting in the same direction, or we can write F2 plus F1, whatever that is your wish. But according to the numerical 1, 2, 3 we can go. Okay, starting. That's why simply we can take in that F1 plus F2 because of both are acting on the body only one direction. That's why we can take it as addition symbol here. This is the formula to find if two forces acts on a body in same direction. Now, for understanding of you, I will tell one example here. A person is applied 10 Newton on the table. B person is applied the 5 newtons on the table. That's why what is the net force is acting on the table? So F of net is equals to F1 is nothing but A person force 10 plus F2 is nothing but B person force 5. That's why 10 plus 5 15 Newton means totally 15 Newton force is acting on the table in the same direction. Next, case number 2. If two forces are acting in opposite directions, listen very carefully. If two forces are acting in opposite direction, what is the net force? How we can find? Now for this one, so we discuss the two examples. Example 1 here. Okay. It is we are considered as a table. Okay. Table is there. Now, one person A push this table with F1 force towards the east. So listen, A person is push the table with F1 force towards the east. Next, another person we are considering in the other side. That person is B person. He push the table with F2 force towards the west. Okay, listen very carefully. A table initially a table is on the surface of the ground. Now on the table A and B, two persons are apply the force simultaneously. Is nothing but at a time. A is apply the force on the table towards the east, and B is apply the force towards the west. That's why. So he was the east direction, he was the west direction. Both are acting in the same direction? No, both are acting in the which direction? Different or opposite direction. That's why how we can find f of net is equals to then f1 minus f2 or f2 minus f1. Means among the f1 and f2, which one applies the more force? That is first you can take in. Other one we can take in the next. That's why if f1 is more than the f2, we are using which formula? f1 minus f2. If f2 force is more than the f1, we are using the which formula? f2 minus f1. Normally is also you can use it, but it is the easiest way. Without confusion, we can find the net force acting on the table when two persons are apply the force in opposite direction. Now in this one, we consider the two sub cases. First one, or A, I will consider. What is the first one? Means A and B, the two persons are push the table in opposite direction with equal magnitude. Means A is apply the 10 Newton force, B is also apply the 10 Newton force. In which direction? A is towards the east, B is towards the west. That's why forces are same, means you can use the formula either this one or this one because of magnitude is the same. Then F1 is 10, F2 is 10. What is the value? 0. That's why the table is set into the motion or not. Here, listen very carefully. If two forces are acting in opposite direction on a body, during that condition, the two forces are equal in magnitude. Means both are push the table with the same force in opposite direction. During such condition, table is set into the motion or not? No, it remains in the rest because of the net force is acting on the table is 0. Next second case. Now, in the second condition, means B. A person push the table with 20 Newton force towards the east. B person push the table with 10 Newton force towards the west. That's why what is the f of net concept according to this one? So 20 is more greater than the 10. That's why it is f1. We are consider it is we are consider as a positive. Sorry, but it is we are consider the main. First one, it is the second one. That's why F1 minus F2, we can write the formula. Because of, for the F1 force, F2 is in which direction? Opposite. Opposite means minus. Same means plus. Listen, if two forces acting on the body in the same means we can consider the plus symbol between the two forces. Opposite means we can take in the minus. That's why, what is the F1 value? 20. What is the F2 value? 10. What is the resultant? 10 Newton force. Means, now in this case, they are asking one type of question. F1 is 20 Newton, F2 is 10 Newton. So, if the two forces are acting on the table or body simultaneously, the resultant force is acting in which direction? Now here, so 10 Newton force is mainly difference. Between which one? F1 and F2 means is nothing but F1 is applied 10 Newton more force than the which one? B. That's why when according to this situation F1 force is more than the F2. Due to that one, table is always moves towards the east only. If just we are consider here, F1 is 10 Newton, F2 is 20 Newton. What is the formula? Here we can write 2 here. 1. F2 is 20, F1 is 10, finally 10 Newtons. Means, so the B person will be applied 10 Newton more force than the A person. That's why the table must be moved towards the west. Means simply what you understanding, when two persons are apply the forces on the table in opposite direction. Which person is applies the more force on the body? That side the body will be set into the motion. Next, second case in the same thing. Okay, case number 2. Already in the case number 2, one way we discussed that, this is the another one. Means in the case 2, first one, in the first example, I am explained clearly about if the two forces are acting on the body along the horizontal. But if the two forces is acting on the body in vertical mode, what will be happen? It is we are considered as a table. On the table, we place a brick. Okay, all I says that. On the brick, which force is acting downward? Gravitational force. Next, upward, which force? Normal force. It is we are considered as a F2. Now, according to the Earth magnetic field, that's why here, okay, when a brick is placed on the table, on the brick, gravitational force is acting downward, means in the south side direction, and the normal force is acting on the brick by the table in vertically upward is nothing but north side direction. Here we are observing that these two forces are acting in vertical mode but not in the horizontal mode. During this condition also, same formula we can using that. What is the net force? Here, this one you can consider that. Here, F1 is equals to 10 Newton. F2 is equals to 10 Newton. We are considering that. Then what will be happen? Okay, just for understanding of you. That's why F1 is 10 Newton, F2 is also 10 Newton. What is the net force concept? F1 minus F2. 10 minus 10, that is equals to 0. Means here, two forces is acting on the body in vertical direction or vertical mode with equal magnitude but in opposite direction. Formula is F1 minus F2, but the the net force is 0. Next, just for understanding of it, maybe, okay, for assumption of numerical. Okay. F1 is 20 Newton, for example, sorry. F1 is 10 Newton. It is the 20 Newton. Then the body will be moved to which one? Simple is nothing but a person will be trying to lift this brick to the vertically upward. That is meaning of that. That's why, okay, F2 minus F1. Here, according to the diagram, F1 they are given 10, F2 given 20. F2 magnitude is more than the F1. Thus we can write F2 minus F1. What is F2 value? 20. What is F1 value? 10. That is equal to 10 Newton. Means 10 Newton more force is acting on the brick vertically upward. That's why the brick can easily move to vertically upward during the lifting. And one more case is also there. We discussed that. Case number 3. What is the case number 3 means? So it is a table. Like this one here. Here we are observing that means two forces are acting on the table in one direction and one force is acting on the table in another direction. During this type of situation, how we can find the net force is acting? Here totally how many forces are acting on the table? 3 forces are acting on the table, F1, F2 and F3. F1 and F2 both are acting in the same direction. Same means plus. And F3 is acting opposite, means for the F1 and F2 it is in opposite, means minus. That's why what is the formula to find net force? Means F1 plus F2, because of these two are acting in the same direction, minus for these two forces F3 is in which direction? Opposite. That's why F3. Then okay, so this is the main formula to find when, okay, more than two forces or three or four forces are acting on the table in the different directions. Okay, what is the F1 value? 10. What is the F2 value? 6. Minus, what is that one? 8. That's why 10 plus 6, 16, minus 8. Then what is the value? 8 Newton. Means 8 Newton more force is acting on the table towards the east. That's why finally table will move towards this direction. Means east side direction. Next, sometimes same thing they are asking in the different mode. Okay. Like this one, we are considered here. So three forces are acting on the table. F1 is 10 Newton, F2 is 8 Newton, F3 is 8 Newton. Okay. So F1 is acting towards the east, F2 and F3 is acting towards the west. That's why what is the formula here? Okay. F of net is equals to F2 plus F3, because of these two forces are acting in one direction, minus F1. Okay, that's why here we can write that. Or F1 is, what is that one? Generally, why? Okay, we cannot take in the F1 minus F1 minus of like this one. Why we cannot take F1 minus of F1 F2 plus F3 means when you can take in like this one, what is the F1 value? 10. What is the F1 plus F2? 8 plus 8 is 16. Then what is the net force? Minus 6 Newton. But generally, so the force is applied on the body, that is either during the pushing or pulling. Okay, it is force is always in the positive but not in the negative. That's right. Okay, so what we are considering in this one means the magnitude of the force is always positive but not the negative. Okay, but force is a vector concept. According to that one, we are considered the direction. But here minus is represented the not a direction. Here minus is represented which one? Simple. That's why. So minus 6 Newton is represented. That's why the magnitude of the force is always positive but not the negative. Okay, but when you are considered the direction, at that time we can represent it. Minus is represented opposite sometimes. But that is in higher standard level, we are discussing that. But for you it is some difficult. That's why I go for simplest method here. F2 plus F3 means 8 plus 8, 16 minus F1 is 10. That's why 6 Newton. This is the net force is acting on the body. Okay, in which direction? West side direction is nothing but opposite to the F1. So now students, I am giving some homework for you. Okay. So before going to the homework for you, just I will briefly explain which concepts in this video we are discussing in the chapter of force. What are the differences or distinguish between contact force and non-contact force? Mainly, three are we are observing that. What is the first one? You can write the definition on the both sides. A force which occurs direct physical contact between the two bodies. In under the force at a distance, a force which occurs without any physical contact between the two bodies. Under the category of contact force, second one, contact force is depend on the area of contact between the two bodies. Next, in other side, non-contact force or force at a distance is depend on the distance between the two bodies. And the third one is normal force, muscular force, frictional force, tensional force are the example for the contact force. Gravitational force, magnetic force, electrostatic force are the example for non-contact force. And after that, I am explaining what is the net force. Net force is nothing but when two are okay, more forces are acting on a body simultaneously or at a time. That force we are called as net force. In the net force concept, some cases are there. What is the first case? If the two forces are acting on the body in the same direction, the formula is F of net is equals to F1 plus F2 or F2 plus F1. And the second one is if two forces are acting on the body in opposite direction. That's why. So during such condition, okay, we can write F of net is equals to F1 minus F2 or F2 minus F1. But why we can take in the two types of formulas here means, okay, among the two forces, which force will be have the more magnitude? That is here as the first. Okay. Next, the third one is if the two forces are acting on the body, not in the horizontal, they are acting in the vertical. That case also same formula is there. And the final one, case number 3. Okay. Not only the two, so 3 or more forces are acting on the body or system at a time in different direction, not in the same. Due to that one, what will happen? Okay, for example, F1, F2 is acting in one direction, F3 is acting in the another direction. During such condition, okay, so F1 and F2 are acting in the same. That's why same direction means plus. Then F1 plus F2 off. Okay. For the two forces, F3 is in which direction? Opposite. That's why minus F3. Like that one. So that formulas we are using to find the numericals in the net force concept. That's why I am giving the homework. Okay. 3 numericals mainly. So each numerical is belonging to one particular case is there. It is the surface of the ground. We can consider. F1 is equals to 6 Newton. F2 is equals to 8 Newtons. Find net force. Simple. Okay. Find net force. Next, second one is there. Find net force. Next, third one. So, F1, F2 are acting in one direction, F3 is acting in the another direction. Here is also find net force. So, when we are solving these numericals, if you have any doubt, so please ask me through the WhatsApp only. Okay.